Very good evening to you, friends. Once again, welcome to Manthan, another episode of Manthan. In the previous episode of Manthan, we suggested an alternate model of universe to the contemporary classical model of universe. Classical model of universe is based on the existence of gravity. What we did in Manthan was that we exploited the intrinsic contradictions that were present in the classical model of universe, and we tried to uh, challenge the very existence of gravity. And we instead of gravity, we replaced it with spacity. And that model, we tried and showed it to all the contemporary models of the universe, starting from the solar system, the sun and the planets, the way they behave, and then the stars in the galaxy, how they behave, various types of galaxies. It was applied to and showed that it works well. It is not just the contemporary universe, but the early universe also. We applied the spacity model was applied and showed that all really worked well. And then we stretched it to the end of the universe, the possible end of the universe, how it could be. We used Carnot cycle to show that it could possibly be a cyclical universe. Among some of the episodes that we touched on in the Manthan alternate model of the universe was applying the spacity model to double slit experiment, and it was explained beautifully as to how the spectrum behaves the way it behaves. And another episode that we touched upon was the black holes. But our study was limited only to how the black holes are formed. What are the basic parameters of black hole? In the sense, the spin, the mass, these are the basic parameters of the black hole. But during this particular episode, what we are going to do is dig a bit more into the concept of black hole, in the sense how the mass behaves when it nears the black hole and when it crosses the event horizon and goes towards the core of the black hole. How does it behave? So let us start with this particular episode with a few questions. Uh, One may wonder, when the mass nears a black hole, it has infinite options to approach the black hole to reach the core. But we have seen that it takes a one particular path, which is equatorial plane, and it is perpendicular to the axis of rotation. And why does it do so? And we also see that the mass which is nearing the black hole, it is to begin with in the straight line, and then it starts bending, and then it is in circular concentric circles. So to understand this, it will be easier for us to understand if we study the black hole and the magnetic flux around it. You may wonder that magnetic flux is not available, is not existing near the black hole. So once we understand why the magnetic flux does not exist in a black hole, it will be easier for us to understand why a mass takes the path that it finally does. So what is a magnetic flux? Let us say in the case of Earth has a hot molten iron core which is spinning. This leads to the magnetic flux that is generally shown here around the Earth. And this magnetic flux, though in case of the Earth it is a decent strength, it is not something which is having a maximum effect. It has a decent effect, the way we encounter it in the atmosphere. Now compare it with a black hole. Black hole also has a hot spinning core, and it all started with an iron core. The collapse of the mass of the star into a core was basically when the fusion reached up to the stage of iron, and iron was it was not able to fuse any more elements beyond iron, and that is how it started. So what we have is when an Earth which has a molten iron core which is spinning can generate magnetic flux of decent strength, Why is it that black hole, which is many, many billions of solar masses, as heavy as that, and spinning at astronomical rotations, how is it that it has no magnetic flux or no effect? So we need to understand why. To understand this, the basic concept that defines the extent of magnetic flux is time dilation. What is a time dilation? Time dilation is basically that the clock ticks faster in the space than the clock which is on the ground. The difference is almost around 38 microseconds. You may say that it is very small in size, but if it is unaccounted for, the GPS that we use ultimately, if you don't account for it, this particular time dilation, you will not reach your destination. So it is important, the time dilation. But what is time dilation? Time dilation is basically mass affects time also. Generally, it is just said that mass affects the space. It is not just the space, but the mass affects time also. So if you have a massive mass, the effect on the time is also massive. So since the black hole is a massive mass, it will affect the time massively. Let me explain to you what I mean by massive effect. Let us assume the vortex that is shown here is the black hole. Now, let us assume for hypothetical reasons that we have a machine which can put two masses, two bodies in different space, in different positions of space, which are, let's say, billions of kilometers away simultaneously. So let us assume there are two twins born just now, and we use this machine and we put one of the babies near the black hole, in the vicinity of the black hole, and the other baby far, far away, a billion kilometer away, let's say, from the black hole. And when you observe that by the time the child which is far away from the black hole, it would age faster to the extent that by the time it has become an old man, the twin which is near the black hole would still be a baby. So that is how the time is getting affected. In the sense, the closer you are to the black hole, the time slows down to the extent that when you reach near the core, the time almost stops. Now try and imagine what is happening here. What are the various regions of the black hole? Right from, let's say, near the black hole to the accretion disk, the event horizon, and then the void, and then the core. So what we are doing is we are moving radially towards the core. So the distance is decreasing, and hence the effect on time is also increasing. So what's happening is there are various time zones right from core till the beyond the event horizon and in the vicinity of the black hole. Now, let us now see how a magnetic flux could exist in such a situation. We said that since Earth, which has a molten, rotating, spinning core, iron core, even black hole also should be able to generate. It generates the magnetic flux. But let us assume that this is that magnetic flux. It's a filament. So what we are trying to do is, this is that line that I have shown as magnetic flux. As you can see, this magnetic flux has to exist in many time zones. In the sense, this particular part of the section of the magnetic flux is in, let us say, near the core, is T0, T1, T2, T3, T4. In the sense, this physical entity of magnetic flux is existing across the time zones. For it to exist, it will have to exist across the time zones, which is not possible because magnetic flux is a physical continuous structure. The nature of the magnetic flux is continuous in nature, whereas the space near the black hole is divided into time zones, and that is how magnetic flux cannot exist near the black hole. So this is what is going to help us understand why the mass which is nearing the black hole behaves the way it does. So let's go to the next slide. So what we have is, as I said, when the mass which is approaching the vicinity of the black hole, it has many options, infinite options to fall in. Let us assume that it is not a black hole which is spinning. It is just a extremely dense mass, and it has an attractional force. So the mass, whichever way it is coming, it has to come and fall into the black hole or near that mass. Now, the fact that it is spinning, ideally, if it was just a sphere, it can enter from any angle. But now what we see in black hole is that, first of all, it is not straight, in the sense the moment it is coming towards the black hole, it is bending. After bending, it is getting into circular shapes, which in a plane which is perpendicular to the axis, and then which is along the equatorial line. So we need to find out why is that the mass is going through a particular path. Why is it not taking all those infinite options that are available to the mass? So what I have done is I have tried dividing or categorizing those planes or paths which are available for the mass to take. They are basically into two categories. One is off center, another is through the center. When I say off center, 1 and 2, this is 1 which is off center. It is not going through the center, and the other is going through the center. Now again, in each type which is off center, there are two types. One is that it could be at any angle to the axis of rotation, or it could be at perpendicular axis. You can have many parallel axes which are perpendicular to the axis of rotation. And the other two options which are there is going through the center, 3 and 4. These are concentric in nature, and the 4 is the one which is the equatorial plane, which finally the mass ends up taking. So we are now trying to prove that of the 1, 2, 3 and 4, the mass takes only the 4. So we need to eliminate 1, 2 and 3 as options for the mass to take, and then show that the only option left is the line 4. So how does that happen? So let us first address the issue of the curvature. As it can be seen here in this picture, the mass which is getting sucked into the black hole, to begin with, it is straight, and then it starts bending. So how does this bending start happening? Let us assume that we had talked about time dilation and various time zones existing across in the vicinity of the black hole. So let us assume that in the near vicinity of the black hole, where the time is not greatly affected by the existence of the black hole, the time zone is, let us call it as T0. And when it is in the region of T0, the mass is going straight. But moment it hits the region which is T1, which is a different time zone, that is where the threshold of the black hole starts. That is where the time differences start making a sizable difference. That is when the mass which is trying to enter through the black hole, the mass doesn't have a time machine. For it to just go radially forward, it'll have to have time machine, because that's the only way you can cross the time zones. But mass doesn't have time machine, so it'll have to bend in concentric circles around the curvature of the black hole. Now, why does it get into the concentric circle, or why does it get into a circular motion? Is because there is attractional force from the core. So obviously it cannot just stay where it is. It has to either go radially towards the core, which it cannot do. So when it is bending, obviously it is taking the path of the curvature. Now, how does that concentric circle, then how would the mass move from one time zone to the other? If possibly the axis or the rotation of the black hole was stable in nature, the mass would be stuck in a particular concentric circle forever. But the fact that the axis of the rotation is not stable, then the mass has a chance to move into a vortex. Another possibility is that the mandate of the mass is to reach the core. So it will have to somehow cheat the time zone by moving into the concentric circles in a vortex structure, but surely not through time zones T1 directly to T2 to T3 to T4, but going through the concentric circles in vertical form and then trying to reach the core. Now, we have now proved that the mass generally moves into a particular plane, which is concentric circles and having a vortex structure. But then now we need to see why is it that it takes a particular plane, which is equatorial plane, which is perpendicular to the axis of rotation. So let us see 1 and 2. So let us assume that the mass which is going through the concentric circles in this angled position reaches the center, but the center is far away from the center of the core. The mandate of the mass is to reach the core. So this plane is not an option for the mass because the mandate is to reach the core. It is not reaching the core. In the same way, all those planes which are in the nature of 2 also get eliminated. So now we have 3 and 4. Why is it that this is also a concentric circle? In the sense it is going through the center, the plane 3. Why does it not choose plane 3? See, in universe, energy is spent very carefully. It is spent only to the extent of as much as is required. Now try and imagine the mass has 2 options, either time 3 or time 4. Now T1, T2, T3, T4 that is existing on the plane 4, if you drop it onto plane 3, similarly T1, T2, T3, T4, you will see that for a particular time zone, the distance traveled is the highest in plane 3 and it is the least and most efficient in plane 4, and hence the mass, instead of choosing all these planes which are going through the center at an angle to the axis of rotation, it chooses line 4, and hence the plane line 3 get eliminated. So what is left now is only line 4, and the mass chooses only the plane which is shown as line 4. That is how the mass, instead of all the infinite options of falling into a black hole, ends up taking a path which is equatorial in nature and it is perpendicular to the axis of rotation. From this, another corollary that we try and develop is that the much of black hole is empty. When you see the northern hemisphere, if we could call that, northern and southern hemisphere of the black hole above this equatorial line is empty. The mass is limited or concentrated only along the line or the plane 4. So it is in a way follows the accretion disk, the plane of the accretion disk. It keeps following till the mass reaches the core. Now, we have tried and explained why the mass, how the mass reaches the core. But we would want to know what is the nature of the mass once it crosses the event horizon, or maybe inside the accretion disk. Is it in sizes of mountains or small pebbles or molecular in nature? So let us try and see what kind of mass size that we have. As we know, the accretion disk, the temperature that exists in accretion disk is in tens of thousands of degrees or tens of thousands of degree kelvins. So what would happen to any kind of mass which is existing in such an atmosphere? An atmosphere which has temperature as high as this. You pick up any element from the periodic table. You pick up tungsten, which is the mightiest element of the periodic table that we know of. The boiling point of tungsten is around 5,500 degrees centigrade. So even tungsten would evaporate in the atmosphere of accretion disk. Not just evaporate, it would possibly in plasma condition. So we know for sure that it is not in the sizes of mountains or pebbles. Obviously, it is molecular in nature. But is the black hole strong enough to pull apart the protons and the neutrons, or to split the atom, so to say? So for that, let us try and see what is the kind of gravitational force that a black hole has. And let us try and compare it with how much equivalent gravitational force is required to pull out a proton or a neutron of an atom. The biggest black hole that is there in the universe that we have come across is 30 billion solar masses. They are basically classified into the solar mass. One solar mass is the mass of our sun. So you put 30 billion of those, and that is the kind of black hole that is there. This is the worst or the biggest black hole that is possible. Why we are taking that condition is the extreme condition. So if that black hole cannot split the atoms, nobody else can. So what is the solar mass equivalent of G? Our sun, which is one solar mass, generates a gravitational force of 1.6 to the power into 10 to the power 12 G. And the fact that it is 30 billion solar masses, this comes up to 5 into 10 to the power 22 G. And what is the strong nuclear force which is binding the proton in the atom, a neutron in the atom? In the sense, if you want to remove it, you need to be exactly equal or up, beyond more than the binding force of the neutron and the proton. This is 100 trillion G's. This works out around 10 to the power 38 G. So when you compare these two forces that the black hole can exert and the forces which are holding the proton and neutron together, the black hole, even black hole, the biggest of black hole, is unable to split these atoms. So when you go across that plane, across the event horizon, and you have seen the mass which is swirling around, that mass is a soup of atoms, but it is not, how should I say, proton, neutron, quarks, or no, it is still in atomic nature. So another corollary that we want to, because what we are trying to do is how things are inside a black hole. So generally it is asked, all the black hole, the lights for the age of the black hole is falling into the black hole. So is it bright enough inside when you look around, when you enter across the event horizon, or is it pitch dark? So let us assume that there are three masses. You are this mass. There is one mass ahead of you, one mass behind you. And obviously you are not moving radially. You are moving concentrically in this vortex. So obviously the mass which is in front of you is traveling faster than you, and the mass which is behind you is traveling at a speed which is lesser. So you won't crash into each other, but for sure you are following each other. Now, would you be able to see the mass in front of you? If you are able to see the mass in front of you, which means the light which is falling on this is getting reflected and coming to you, then only you can see it. But when you say that the light is reflected and coming back to you, which would mean that the light is trying to escape from black hole, which is not possible. So the light falls on it, but it would not get received by you. So you would not be able to see the mass in front of you. So if you hold your hand, you won't be able to see your hand. So what happens to the mass which is behind? So what happens to the mass which is behind is, first of all, you are eclipsed. So if there is a light which is falling on this mass, it won't be able to reach you, because the mass itself, the mass behind itself, is stopping you from receiving it. There is a possibility that there is black hole, sorry, a light inside the black hole which is falling on this may get reflected to you. In that case, again, a light which has to fall on this surface which is behind you would again mean that black hole is the light is trying to escape from black hole, which is not possible. So in a way, you won't be able to see the mass either in the front or at the back. Only possible thing is, when you're looking at the back, one may ask, what about the light which is coming from the left or the right of the place that you're in? But the problem here is the time zone. You are in one particular time zone, let us say T1, T2. The ones which are near the core is in T3, another one which is away from the core is in T1. These lights cannot cross the time zones. They don't have the time machine. So the light cannot come from the sideways. Possibility is that the light which is directly falling on your eyes, and if your speed is less than the speed of light, you will be able to see just that particular beam of light which is falling on you. So otherwise, inside, it's all pitch dark. Now, another question one may ask is, black holes have been around in the universe for billions of years. Black holes, there are some black holes which are not feeding, some black holes which have been active black holes. That means they have been feeding. And we know that the black hole is basically, the genesis of black hole is started from star mass. And that star mass collapsed into a very small volume. So we know for sure that it is very hot. And this particular black hole is feeding the mass that is falling into it for millions and billions of years through its life. When you are adding so much of mass into a constricted volume, there would be some limit at which time it should explode. It should say, enough is enough, I can't take any more. So it should blast out. It doesn't happen so. We have never seen it, and possibly it will never happen. So why? So we have seen the time dilation. We know there is time zone across the vicinity of the core. So when you have such time zones, as we said, when you move radially towards the core, the time zone keeps changing. The time slows to an extent that when you are just near the core, time almost stops. It doesn't stop, it doesn't come to a grinding halt, but it almost comes to a near grinding halt situation. So what does that mean? The mass is not able to reach the core at all. In the sense, all the mass that is falling into a black hole throughout its life, that has crossed the event horizon and tried to reach the core, has not reached the core at all, because the time around the core stops, or it is very slow. So the mass doesn't reach the core at all. What does that mean? That means the basic constitution of the core is not changing. Its size, its temperature, its pressure, whatever it was when the star collapsed into a core, it remains the same throughout its life. And hence, there is no question of the black hole exploding. This is a tricky question. When I explain to you, you would know why this funny question is put up. Are you able to hold the core of the black hole in your bare hands? We know for sure that this core, the origin is the star mass itself. The star itself is so hot. When you compress it into a small mass volume, obviously it will be much, much hotter, millions of temperature. But still, we are daring to ask a question whether you can hold that core in bare hands. We'll show that it is possible. Of course, you cannot, but just hypothetical. The temperature of the core inside is millions of degrees or Kelvin, whatever. But the surface of the core is at 0 Kelvin. Why? We need to understand what is temperature. Temperature is only a measurement of the heat. The heat is basically the excited state that the mass is in. The heat is getting radiated and you're measuring that extent of radiation. That means if at all you're able to measure the temperature of the surface of the core, means that the radiation is coming out of a black hole or a core of a black hole is a no-go. So all that heat which is there on the surface of the core is pulled in. So at the surface of the core, it will be 0 Kelvin. It's the best black body that one can have in the universe. Black body is defined as a body which absorbs most of the heat. It doesn't let go of the heat. So when you try to measure a black body, the chances are that it is closer to 0 Kelvin. But it is almost impossible. The mass itself, there is some amount of vibration which gets converted into heat. So there will be some kelvins in a mass. But this one, if at all you're looking for a black body, ideal black body, ideal black body is the core of the black hole. This is irony of the situation, something which is so hot, millions of degrees centigrade temperature, is the best black body. So in a way, if you could hold, you can hold it in your bare hands. Now, we all know, $1,000,000 question, simple, you cannot escape a black hole. But shall we try and find out, is there any way to escape black hole? So what is escaping from black hole? Black hole, in the end, it is just mass, just the way Earth is. How do you escape from Earth? You have escape velocity. How do you put a satellite in the space? You make that satellite or the rocket fly at a speed beyond more than the escape velocity. In case of Earth, it is 11 kilometers per second. So you increase the mass of the planet that you're trying to escape from, like Jupiter, it would be 60 kilometers per second. In case of a sun, it will be 615 kilometers per second. In the sense, the escape velocity is increasing. So obviously, when we are talking about black hole, which is millions and billions of solar masses, the escape velocity will be infinite kilometer per second. So generally, it is said that it is almost impossible for you to escape the black hole in a way way we escape from Earth. But as for the sake of hypothetical discussion, let us assume I give you infinite energy. Go ahead and escape from the black hole. We are saying you need infinite energy to escape from black hole. I give you infinite energy. Go out. Is it possible? It is not. What is more important is infinite energy is only the magnitude, and what is important in escaping from black hole is direction also. In case of Earth or Sun or Jupiter, the direction is very clear. It is radially outwards. You try doing that in a black hole, you cannot, because you don't have a time machine. For you to move out of the black hole radially, you need to have time machine. Even if you have infinite energy, it is not going to help you. So it will have to be concentric. We know that the mass, if you're falling into the black hole, you're taking that concentric circle of the vortex structure. When you want to escape, now it has to be through that concentric circle. So when you are in the concentric circle, there are only two ways to escape. One is either move forward or backward. Moving forward doesn't make sense. If you're moving forward, you're going more towards nearer the core and you would not be able to escape. So the only option left is backward. For you to move backward, you have to, apply the brake, come to a halt, and then change your direction, and then possibly try to come out of the black hole. You have the infinite energy. But we will see that possibly even that is also not possible. To understand that, we need to study a bit about how the speed of the mass and the time around the time zone around the black hole uh, works. Now, we know that speed is distance traveled divided by time. When let us assume that you are away from the black hole, you are moving in concentric circles. The speed there is s by t. The speed, the distance traveled is the circumference of the diameter at this particular time. And let us say t is t, time taken. When you try moving radially towards the vicinity of the black hole, what happens to these three parameters? We know for sure that the distance traveled will be lesser and lesser relative, because the diameter is reducing, the circumference will also reduce. And what happens to the velocity? Velocity should increase, because the more closer you are to the core of the black hole, the attraction force is more, so the speed is far more and more. Now, what happens to the time? The denominator. Generally, what you see here, we say that as you near the black hole, time slows and it comes to a grinding halt when it is at the core. When you say when it slows down, or when it comes to a grinding halt, is t is equal to 0? T is not is equal to 0. T is in fact is equal to infinity. In the sense, the time is slowing down, in the sense time is also increasing as you move towards the black hole. Time is also increasing. But look at this equation. If the velocity is if the distance traveled is decreasing and the time is increasing, which means that the numerator is decreasing and the denominator is increasing, the result, which is speed, has to decrease. But we know the logic says that closer you get, the velocity increases. So how do we explain this conundrum? Important is to understand what is plane of reference, in the sense, when you are looking from an external area towards inside the black hole, the time seems to be slowing down, because the plane of reference here, the time, which is t is equal to 1 second, this would look like time which is 1000 seconds, which is nearer to the black hole. And that is why you may feel that a person in that particular um, time zone is aging less, aging slowly. But what is most important is, if you go to a particular time zone, the time zone of this twin baby, which is nearer the black hole, life would be going on normally for it. For it, the 1 second is 1 second. That 1 second is 1000 seconds for the grown old man who is far away from the core. When he looks from there, for him it is 1000 seconds. But for the baby, it is still 1 second. Life is going on normally, which means the time, when you relatively look from outside to inside, the time is slowing down. But when you are in a particular time zone, time is behaving normally, in the sense t is constant. So let us take out t, time, out of the equation and see, when you are trying to move inwards, radially inwards, we want the relative speed to be increasing. I am saying relative speed. It should be increasing. For that to happen, the relative distance the distance traveled also has to increase. But this is a contradiction. When you're moving inwards, the relative distance is in fact decreasing. The only way the velocity can increase when the distance traveled is decreasing is when when the space is slipping. Very similar to a treadmill. So you are increasing your speed, But for others, you are seen as though you are standing in motion. And when you increase the speed of yours, you will have to increase the speed of the treadmill also, so that you are in motion. So in a sense, a mass travels 100 meters, the space sets it off by 100 meters. So when that 100 to 100 is 1 is to 1, that is when you feel the time is stopping. But otherwise, time is moving. So that means the space around the black hole is slipping. It's acting like a treadmill. So what will happen to our escape plan if the space around the black hole is slipping? So let us assume you have that infinite energy that I had given you. You applied the brakes. You came to a grinding halt. Now you want to use that infinite energy and try going backward. Again, when you're going backward, the time slips, the space slips again. So whether you are moving in the concentric circle forward or backward, the space always slips and you will never be able to come out of the black hole, even using your infinite energy. So how to come out? Infinite energy is out of question. The only way that you can come out without any energy is if you have a time machine. You have a time machine, change the time, you will move to the next concentric circle away from the black hole. So you keep changing the time, you automatically move outwards and your speed is slowing down, because when you move towards the core, the speed is increasing. When you're moving away from the core, the speed is decreasing. You keep doing that to such an extent that you come to T0, which is a normal time zone where black hole doesn't have any effect. So the only way to escape black hole is if you have a time machine. After black hole, we would like to talk to you a bit about the Big Bang. Whenever something is said about Big Bang, it is said that it is all of this universe started at Big Bang. And this is the classic picture that you come across. You put in Google Images, Big Bang, this is what you will get. What I say is there is an error in this picture. And we will see what the error is. Basically, the Big Bang is, this is the contemporary universe as of now. So Hubble observed the night sky and he found that all these galaxies are moving away from each other because they were all redshifted. So he inferred that if they are moving away from each other, there should have been a time in the past when all these masses, galaxies of all these masses, would be starting from a single point, and that point was known as Big Bang, which is shown here. And this is 13.8 billion years before. So let us try and understand that to find this error, we need to analyze what is a mass, what is energy. So let us talk about it a bit. Pure energy. Energy, I don't mean to say electricity, magnetic force, heat. These are all energy which are based on mass. I'm talking about pure energy. Pure energy does not interact with mass. It just flows through you. You cannot measure pure energy because it doesn't leave any fingerprints. You can't weigh it, you can't find its temperature, there is nothing. Pure energy doesn't have these parameters. All we know about pure energy is it moves from a higher density to a lower density, that is it. Whereas in case of mass, it can be detected. It has a size, shape, weight, volume. You can touch it, you can feel it, you can see it moving, it can cause damage, it can alter its vicinity. So we know mass, we can detect it. It's not just when it is near you that you can hold it. Even if it is billions of light years away from you, you can still see or detect that mass. How? Because of the fingerprint that it leaves. What are those fingerprints? These fingerprints are electromagnetic waves, EMWs. Based on the state of the mass that it is in, it emits these waves. These waves are, let's say, the most unexcited form of mass, the black body, generates radio waves. whichever mass that you have has to generate radio waves. You excite it a bit more, then you have microwaves. Excite it a little more, you will have infrared waves. So after the infrared, you have red, and then you have the visible light spectrum, which is basically red, orange, yellow, green, blue, indigo, and violet. Excite it a little more. Beyond violet, you have ultraviolet, X-rays, and gamma rays. These are the ones which are more dangerous. But generally, what you see is all these types of waves are basically fingerprint. And the visible light is only one part of that fingerprint. So we can say that light is just another form of mass expressing itself. In the sense, if there is light, there is somewhere mass. Or if there is radio wave, there is mass. So if there is light, there is mass. If there is no mass, there cannot be any light. So this is obvious in nature. So Big Bang is a state of pure energy. I'll explain you why we are talking about Big Bang being pure, state of pure energy. When I say it's state of pure energy, there is no mass when it all started. The Big Bang, there was no mass. But how do we prove that there was no mass? Let us assume, for the sake of argument, that Big Bang was all mass. It was not pure energy. If it was mass, the prevailing temperature and the pressure, imagine the mass of the universe is concentrated in one single point. The pressure and the temperature would be astronomical, infinite pressure and infinite temperature. If mass is existing at that state, the Big Bang would then be the best forger of elements of the universe. We have this periodic table, the elements. We know for a fact that it starts with hydrogen, helium, and it keeps on adding on, having complex elements. These complex elements are said to be forged in the heart of the masses, the mass of the star. These stars, they started with hydrogen and helium. And then when they met their end of life, they went supernova or whatever. And then new bigger mass of stars came up, and then higher elements of the periodic table were forged inside those bigger masses. So one thing that we should know is that astronomers consider hydrogen and helium as the only two gases. The rest of them are all metals, considered as metals. Even oxygen, the gas that we breathe, nitrogen, they are all called as metals. Just the way you consider copper or gold, everything is metal. Only non-metal element is hydrogen and helium for astronomers. So if the Big Bang was mass, the temperature and pressure which is available for the mass to produce more complex elements would be the ideal condition. Then you would possibly have all the elements of the periodic table at the time of the beginning of the universe. Possibly even beyond the periodic table, because periodic table is something which is always evolving. Now, what does that mean? So when you look back into towards the Big Bang, near the Big Bang, you should be able to detect all these metallic atoms, oxygen, gold, iron. You don't. What you see is only hydrogen and helium. This is what proves that Big Bang was all pure energy. Mass came far, far later. So when we say Big Bang is pure energy, see what happens to this picture. Big Bang is pure energy. Pure energy means there was no mass. When there is no mass, how can there be light? There was no light at the beginning. The pictorial representation that you see here is the error that I was talking to you about. Maybe it is shown because it looks good. It's soft on the eyes, that there was an explosion. Of course, the explosion there, but it was infinite energy concentrated in a particular, an infinitesimally small point, and that dense energy, by the very nature of energy, it dissipates from higher density to lower density. It escaped. So there are some more corollaries that we can talk about. Another error in the definition is when you put Big Bang definition in Google, this is what you get. Much of what is said is right. Rapid expansion of matter from a state of extremely high density and temperature, which according to blah, blah, blah. All is well except for the ones which I have marked here as high density and temperature. When you say high density and temperature, or for that matter, hot and dense, this is not right. When you talk about Big Bang, it is pure energy. Pure energy is never hot and dense. It could be dense, but it not in the sense of pressure. Heat and temperature and pressure are parameters of mass. Big Bang is not mass. So when you define Big Bang, you should not use, I feel, hot and dense. Hot and dense is when you relate to mass. So Big Bang, when it started, that temperature was possibly 0 Kelvin, because there was no way mass was there, and for the temperature to be there, you need to have mass. And the possibly other corollaries is that hypothetically, we have a time machine. I take you back from here. I take you back 13.8 billion years, exactly to the point where the Big Bang is happening just by your side. Will you be able to survive? Yes, you will be able to survive. Though it is the biggest explosion of the universe, you will still be able to survive, because Big Bang is pure energy. Pure energy does not interact with mass that is me. So you will survive the Big Bang. Of course, once the mass comes into picture, you won't be able to survive. But I'm trying to say that when you go to the Big Bang, at the point when it started, you won't be even able to know that the Big Bang has started, and it would not destroy you. And then generally it is said that we don't know what black hole is. We don't know whether it is mass or pure energy. For sure, black hole is pure mass. If it was pure energy, it would not have attracted mass, because energy does not attract mass. It does not interact with mass. So we should take this off our mind, that black hole is a confusion about whether it is mass or energy. It is pure mass. And it is also said that, basically black hole and Big Bang, they have the same premises, where the mass is concentrated in a very infinitesimally small point, both black hole as well as Big Bang. So it is generally asked, how is it that nothing can escape black hole, but everything can escape a Big Bang? That's because black hole is mass, as we just said. So mass attracts mass. So it won't let mass go out of black hole. Whereas Big Bang is pure energy. Though it is again concentrated in a small area or a volume or a point, it is pure energy. Pure energy from a dense area dissipates to a less denser area, and hence everything escapes. The infinite energy escapes the Big Bang. Then it is generally said that nothing can escape black hole. Of course, nothing, no mass can escape black hole. But there is something which enters black hole and exits black hole without being affected. We say that no mass can escape black hole. The answer lies in there. No mass can escape. Anything which is non-mass can escape. So what is a non-mass? There are two entities which are non-mass. One is space, another is pure energy. How does space enter and exit? We know that black holes move in space, that they travel along the galaxy. So that means the black hole is moving through the space. You reverse it, the space is moving through the mass of the black hole. So before going into the black hole, the space was as it is. Whatever happens inside the black hole, when it comes out, the space is still the same. So space is something which is moving inside the black hole and coming out without being affected. Another thing is pure energy. Why I say pure energy is, let us assume that black hole doesn't allow even pure energy to escape from it. So this black hole, we have a galaxy like this. So the black hole is not only at the center, that is a supermassive black hole. Black holes are there all around the galaxy. Thousands of black holes are there. Just the way stars are moving, star goes supernova, stars become dwarf star, neutron star, black holes also. So black hole, once it is formed, it doesn't stop there. It keeps moving because of the inertia of the mother star. It keeps moving in the same direction the star was moving. So when the black hole is moving, on your left side, interior, you have the supermassive black hole and all the masses till you. And then beyond you also, you have all the stars which are moving around the galaxy. Let us assume now the pure energy is not escaping. So I am the black hole now. The effect of all the mass of the stars which are towards the interior of the galaxy, that effect I will not let pass through me to affect the outer part of the galaxy. All the pure energy, gravity, or whatever you call it as, spacity, it gets stuck inside the black hole. Then all these stars which are the exterior part would be free to move around because they are beyond the effect of the masses which are in the center. This would mean that you are taking a scissor and cutting through the galaxy along the path of the black hole. And we know that nothing like that happens. The black hole moves as it is. All the stars on the exterior and the interior side, they move as they keep moving. So that means that the black hole is allowing pure energy to pass through it. So this is what I wanted to talk to you about. I hope it was interesting to you. If you have any questions, please do put it in the comments. Thank you. Thanks for listening.